Alright, I have your answers up here. 15 and 16 didn't do a whole lot. The period didn't change for either. So for 15, it was just moved up and vertically stretched. For 16, really just everything shifted.
There's no amplitude for tangent?
Ever.
And no midline either.
Correct.
Okay.
So some of these examples, when the period changes and it shifts, sometimes you don't see that shift, but sometimes you do. It just depends on what has been done to it. In this case, there was no period change, so when it shifted, the asymptote shifted as well. So just be mindful of that. For 15, without the table, if you're doing, without the table, the original is -1 to 1. Multiply first, so 1.5, -1.5 to 1.5. Add 3 to both of those. 1.5 to 4.5.
So we do that in our head for like the test, or we would have to
You could do the table, or you could do it in your head.
For number 16, the x-intercept, what is that?
Pi over 2 plus pi k,
Okay.
comma 0. So if you didn't get some of the characteristics, you can get those later.
For 16, you can just add pi over 2 to all the x's.
Was it plus or minus? You're really subtracting pi over 2.
So subtract all the x's by pi over 2.
Correct. So we did 17, 18, and 19. 20, a couple different things happened. So I can put the final table up here in a second. Your period was compressed by pi. It was compressed in half. So now really it should be in between 0 and pi. But it was shifted left 3 pi over 4, so now it's starting back here and moved up 4. So I started by taking it and compressing it first. That would have started it and stopped it at 0 and pi, those x values. And then because it was shifted left 3 pi over 4, I did that first. I moved both of those points 3 pi over 4 to the left, and then moved both of them up 4. Just so you have it, the final table for that one was this.
Wait, you're doing the final?
Yeah, just the final table. So in this case, if you did the table, all of those points would have been something on the graph that was easy to determine. Points that you could find on the graph. I keep running into this chair. Questions on this one? Yes.
How could we do like subtract fractions and whatnot?
So with that, think about them as on your unit circle. Or think about them as 3 pi over 4 is really negative 0.75. So the first one was easy. If I'm thinking in quarters or like money, if I have a quarter and I subtract 75 cents, I'd be left with -half. I'm thinking like that because it's really the same thing. had 50 cents and I subtracted 75, I have negative 25, negative 5 or 4. So think about it like that. Right. 21, if your points don't match exactly, it's fine. Because really, a lot of these points were moving by pi over 6s, and that's not what this graph is made of. The x's are pi over 4, so you would have in-betweens. Now, you could go through and count pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. You could count it like that, but it would just be in between some of the points. They'd be a little off. I did not expect you to find this x-intercept, but really, because it's going to go back to this, I just picked one of these points. I knew my first one started at pi over 6, and I added the period to it. So it started at pi over 6. I'm adding 2 pi over 3. Every 2 pi over 3, it should touch it again. Or every 120, it should touch it again. Logan?
Can I ask a question on number 20? So if the period's pi, why is it coming back to the midline at every pi over 2?
It was shifted left 3 pi over 4. If it wasn't shifted like that, then it might not be doing that. Because both of those things happen, I guess is the answer to your question. Really, that's just how it happened to work in this case. Question?
So this one, because I don't know. I'm just really confused, but I don't know what I'm confused about.
Like with the table?
So,
I can explain it just because we don't have much time.
okay.
So with your table, you have four transformations. So 2 are gonna go to your x's, 2 are gonna go to your y's. You're going to multiply first for both. Multiply your x's by 1/3, your reciprocal of 3.
And you got that because it's inside of them?
Mm-hmm.
Okay.
And then multiply your y's by negative 3. I did need to write this up here also. Because of both of these being inside, you had to do this part first. And I should have wrote this up here. So if you did not do that part first, your phase shift is messed up. Your graph is messed up. You have to factor out that number in front of x first.
Okay. So,
Let me go ahead and write that for this one too.
oh, and that's how you get your period? Because it's like x.
Well, your period is still 2 pi over b, but to get your phase shift, which I also did not write up here. To get your phase shift, you would need to factor that part out. After you multiply, then you would subtract pi over 6 to your x's, subtract 3 to your y's. To get that final table. Ethan.
Let's say 1/6. Left 1/6.
Left pi over 6. Now with 22, you could have still done the table for this one, but your period became pi over 2. So every pi over 2, it needs to repeat itself. If we shifted that left pi over 4 with its period change, it actually goes back to 0 and pi. So this one, you can't really see the phase shift unless you're kind of talking or thinking about the ones in between. Because usually it starts at 0, 0, but it has been shifted left pi over 4, so you can see it with those points, just not necessarily the asymptotes. It's been shifted down 2, it was stretched by 2, so take that original, it was shifted left pi over 4, down 2, in the middle would be where you would find all of those middle points, and then go up 2 to the middle, up 2, down 2 to the middle to get your curves. Just so you have it, if you did it this way, this is your final table. Anytime you get something pi over 8, pi over 16, somewhere in the middle. It's somewhere in the middle. Questions on that one? So we're going to graph one of cosecant or secant and talk about its characteristics, see how much time is left, see if we can do the other one today. If not, we'll do it tomorrow. The main thing about these reciprocals is that you have to remember that main thing. They are reciprocals. They are opposites of whatever the original function is. So I'm going to put cosine's function up here, the original. So we have a basis. The points that are 1 and -1, secant can still be those points because the reciprocal of those numbers are still those same things. But anytime it hits 0, anytime cosine hits 0, secant will then be undefined. Secant will have asymptotes anywhere where cosine is 0. Which also means this will not have an amplitude, this will not have a midline, because it doesn't go back to that point. Because of the asymptotes, this is going to look a little weird. So we're still going towards the asymptotes, but in this case, these are going to be mini parabolas. Whoa, I did that one wrong. Now, the reason these go in this specific way is because it can't go past the cosine function.
Whoa.
So it has to go up and down. It can't go past those two. So when we're talking about secant, the way I kind of have told students in the past to remember secant is that it's part of one, a whole one, and part of another one. Our graph is a little bit bigger, but if we're starting at the x-axis, y-axis, I don't know why I said that. If we're starting at the y-axis, there's part of one, whole one, and then part of another one. That is secant. It repeats itself every 2 pi just like sine does. domain is everywhere except at our multiples of pi over 2. So secant and tangent have the same asymptotes if nothing is shifted. So every odd multiple of pi over 2. Your range is not all real numbers though, because it's not in between these two. So it's from negative infinity to negative 1, union 1 to infinity. Or you could write it like this. Because it doesn't go around our x-axis, it won't have x-intercepts. This one has a y-intercept at 0, 1. Our asymptotes match our domain. And we don't have a midline. So you could do secant just like you do any of the others. If you're using the table though, you're using these values right here. Same x's as sine and cosine, but your y's are now whatever cosine was, except wherever it was 0, put undefined there instead. So it's basically cosine's table, except now it's undefined instead of 0. So we will do cosecant tomorrow. We'll do one of each type of example for those, and then we'll do cotangent, and then we'll be done. I did put on the board, I changed the test dates to Thursday and Friday. But I didn't change the quarter test dates, but I need to. So we'll get to that.